Good morning everyone, myself Rahul Kurla. So today I am going to take class on the topic DC generator. So before going into this particular topic, I'll just give a quick recap on the previous class. So in the previous class I explained about the electromagnetic induction process. Okay. See, in electromagnetic induction process, I already explained that there is a coil. Okay, this is the inductor coil which is connected to the galvanometer, and this inductor coil, here there is a bar magnet which is placed near to the inductor coil. Okay. So what happens initially when the bar magnet is moved from a right side to left side, the magnetic field lines which is linked by the coil by the bar magnet with the coil will be high. That is because the bar magnet is moved from right to left, so it is coming close with the coil. So that time the field lines which is linked by the bar magnet will be high. Okay. Now when I move the bar magnet from left to right, the magnetic field lines of the bar magnet which is linked with the coil will be reduced because it is moving away from the coil. So there is a change in the magnetic field which is linked with the coil. So what happens? This will create a potential difference or a EMF. Okay. And due to this potential difference, a current is developed. So this is the principle of the electromagnetic induction. So same principle works in the generator. Okay. So here in generator we can see that there are two poles. One is the north pole and one is the south pole. And as we all know that the magnetic field lines in a magnet always moves from north side to south side. Okay. And in between I have placed an armature coil. It is a coil, and we say it as an armature coil, and this coil is like it's placed between the two magnets, and the tip of the armature coil is connected to a commutator. Okay, it's commutator, and on either side of the commutator we can see there are brushes. Okay, the purpose of commutator is to convert the AC to DC current. That is because here we are studying on DC generator. Okay, so in DC generator what happens is that we get an output in terms of AC. Okay, so in order to convert that AC into DC, we provide a commutator. Okay, and these brushes are basically used to conduct the current. Okay, and so that this current which is conducted will be sent to the load. Okay, so now I will explain the principle of this DC generator. So what happens is that initially this coil, just imagine this is the coil, and on either side of the coil, this is coil, and on either side we have two magnets. Okay, so as you all know that in a generator we provide external mechanical rotation, and with this external mechanical rotation only we generate the current. So initially I will rotate the armature coil, that is I will provide external mechanical rotation. So what happens? Initially when I rotate, it will be in this position. When I start rotating, it will come to this position. Okay, so now what happens? The magnetic field lines which is linked with this coil will be high because on either side there is a magnet, right? On either side, that is here also there is magnet, and here also there is magnet, and there is magnetic field lines are going right from north to south. So in between only we have the coil. So the magnetic field lines which is linked by the coil will be very high. Then again if I rotate, what happens? It will go like this. It will go like this. Okay. So what happens? The magnetic field lines which is linked by the coil will be reduced, right? So again when I rotate, it will come. What happens? It will come again to this position. So what happens? The magnetic field lines which is linked by the coil will be high, and again when I rotate, it will come like this. So at this point, the magnetic field lines which is linked by the coil will be reduced. So altogether what we can see is that there is a change in the magnetic field lines which is linked with the coil. Okay, so same concept is with the electromagnetic induction. That is, in electromagnetic induction we have already learned that when there is a change in the magnetic field, which is linked to the coil will create a potential difference and thereby creating the current. So here also same thing happens. Here also there is a change in the magnetic field happening, and this change in the magnetic field when linked with this coil, that is this armature coil. Okay, that is when the armature coil is rotated, naturally there is a change in the magnetic field happening. So this change in the magnetic field when linked with this armature coil will create a potential difference, and this potential difference will thereby develop a current. And this current is basically an AC, and we convert that AC to DC using a commutator, and this DC is conducted using a brush to the load, and we get the output current. So a quick recap, what we do is that this generator works on the principle of electromagnetic induction principle. That is, what we do, we rotate, we provide external rotation to the armature coil. So initially the armature coil is like this initial state, because and on both sides there is a magnet. When we rotate, initially it will become like this. So at that time the magnetic field lines which is linked with the coil will be high. Then again when we rotate, it will become like this. That time the magnetic field lines which is linked with the coil will be reduced. So this process repeats. So there is a change in the magnetic field lines which is linked by the armature coil. So this will create a potential difference and thereby creating a current. And this current is basically AC, and we convert that AC to DC using a commutator, and this current is obtained to the load. So this is the basic principle of the DC generator. So I hope you all have understood the topic. If there is any doubt, please message or please give the particular comment box below the video.